Introduction to the Multiverse Theory. The concept of the multiverse has captivated scientists, philosophers, and the general public alike, inspiring a blend of wonder and skepticism. At its core, the multiverse theory posits that our universe is just one of many, potentially infinite universes that coexist. This idea challenges our understanding of reality and invites us to reconsider the very nature of existence itself. Historical context. The roots of the multiverse theory can be traced back to ancient philosophical musings. Early thinkers, such as the Greek philosopher Democritus, speculated about the existence of multiple worlds. However, it wasn't until the 20th century, with advancements in physics and cosmology, that the multiverse concept gained serious traction. The modern formulation of the theory began with the development of quantum mechanics. In the 1950s, physicist Hugh Everett III introduced the many worlds interpretation, suggesting that all possible outcomes of quantum events actually occur, each in a separate branching universe. This radical idea laid the groundwork for a broader understanding of the multiverse. Theoretical foundations. Several theoretical frameworks propose different types of multiverses, each with its own implications. One prominent theory is the concept of cosmic inflation, introduced by Alan Guth in the 1980s. Inflation posits that the universe underwent an exponential expansion just after the Big Bang. This expansion could lead to the creation of bubble universes, where different regions of spacetime behave independently, giving rise to distinct physical laws and constants. Another significant contributor to multiverse theory is string theory. This framework suggests that the fundamental building blocks of the universe are not point-like particles, but rather tiny, vibrating strings. String theory predicts a vast landscape of possible universes, each with its own set of physical properties, arising from different configurations of these strings. Scientific evidence and challenges. While the multiverse theory is theoretically compelling, it presents significant challenges in terms of empirical validation. One of the most significant hurdles is that other universes may be fundamentally unobservable. The laws of physics as we know them are based on our universe's specific conditions, making it difficult to test the existence of other universes directly. However, some researchers argue that certain indirect evidence could support the multiverse. For instance, anomalies in the cosmic microwave background radiation, the afterglow of the Big Bang, may hint at interactions between our universe and others. Additionally, the fine-tuning of physical constants, which allow for the existence of life, could be explained by a multiverse where countless universes exist with varying properties, and we just happen to reside in one that supports life. Philosophical implications. The implications of the multiverse theory extend beyond the realm of science and into philosophy. If multiple universes exist, questions arise about the nature of reality, free will, and the uniqueness of our experiences. Philosophers and theologians have long debated the implications of a multiverse on concepts such as destiny and purpose. If every possible choice unfolds in a separate universe, what does that mean for the significance of our decisions? Moreover, the multiverse theory challenges the anthropic principle, which suggests that the universe's physical constants are fine-tuned for the existence of life. In a multiverse, the existence of life becomes less extraordinary, as there would be countless universes where conditions are conducive to life, making our universe just one of many where life could emerge. Cultural impact. The idea of the multiverse has permeated popular culture, influencing literature, film, and art. Works like the Dark Tower series by Stephen King and films such as Everything Everywhere All at Once explore multiversal themes, inviting audiences to ponder the nature of reality. These cultural representations reflect a growing fascination with the multiverse and its implications, making complex scientific ideas more accessible to the public. Conclusion: the multiverse theory represents a profound shift in our understanding of the cosmos and our place within it. As we delve deeper into the nature of reality, the prospect of multiple, coexisting universes challenges our perceptions and stirs our imagination. While the theory has its skeptics and presents significant scientific challenges, it remains a tantalizing frontier in both physics and philosophy, promising to reshape our understanding of existence in ways we have yet to fully grasp. As research continues and our knowledge expands, the multiverse may offer insights that redefine the very fabric of reality itself. Types of multiverse theories. The multiverse theory encompasses a fascinating array of concepts, each with its own implications for our understanding of reality. Various frameworks propose different kinds of multiverses, and these can be categorized into distinct types. Understanding these categories not only sheds light on the nature of our universe, but also invites contemplation of the broader cosmos. 1. Quantum multiverse. The quantum multiverse is rooted in the principles of quantum mechanics. In the 1950s, physicist Hugh Everett III introduced the many worlds interpretation, MWI, which posits that every quantum event creates a branching of the universe into multiple, non-communicating outcomes. For example, when a particle is observed, the universe splits into different branches, one where the particle is in state A and another where it is in state B. This interpretation challenges the classical view of a single, deterministic universe. Instead, it offers a picture of a vast, interconnected web of realities where every possible outcome exists simultaneously. While the MWI resolves some paradoxes of quantum mechanics, such as Schrödinger's cat scenario, it raises philosophical questions about identity and existence. If every choice leads to a different universe, what does that mean for our sense of self and agency? 2. Cosmic inflation theory. Cosmic inflation is another cornerstone of multiverse theory, introduced by Alan Guth in the early 1980s. According to this theory, the universe underwent a rapid expansion shortly after the Big Bang. This inflationary period could give rise to bubble universes where different regions of space-time inflate at varying rates, leading to distinct universes with their own physical laws. In this framework, our universe is just one bubble in a much larger multiverse. Each bubble could have different physical constants and laws, resulting in a variety of environments, some potentially hospitable to life, while others are inhospitable. The idea of cosmic inflation not only explains the uniformity of the cosmic microwave background radiation, but also supports the possibility of an infinite number of universes, each with its own unique characteristics. 3. String theory and the Landscape Multiverse. String theory proposes that the fundamental constituents of reality are not point-like particles, but rather tiny, vibrating strings. This theory leads to a vast landscape of potential universes, each arising from different configurations of these strings. In this landscape, the number of possible universes is staggering, estimated to be around 10 to the power of 500 or more. The Landscape Multiverse emerges from the idea that different string theory solutions correspond to different physical laws. Each universe in this landscape could have different dimensions, forces, and constants, leading to a rich tapestry of realities. This approach not only expands the boundaries of theoretical physics, but also suggests that our universe, with its specific properties, is merely one of countless possibilities. 4. Mathematical universes. The concept of mathematical universes takes a more abstract approach. Proposed by cosmologist Max Tegmark, This theory posits that all mathematically conceivable structures correspond to physical realities. In this view, if a mathematical model can describe a universe, then that universe exists. This radical perspective implies that there are universes governed by entirely different mathematical laws, resulting in realities that may be unimaginable to us. For instance, there could be universes where the laws of geometry differ from our own, or where time behaves in a non-linear fashion. The implications of this theory challenge our understanding of mathematics and its relationship to physical reality, raising questions about what constitutes existence itself. 5. The anthropic principle and the multiverse. The anthropic principle is often discussed in conjunction with multiverse theories. It suggests that the universe's physical constants are fine-tuned for the existence of life, leading to the question, why are these constants so conducive to life? The multiverse provides an answer by proposing that in a vast ensemble of universes, some will inevitably possess the right conditions for life. This principle can be categorized into two forms: the weak anthropic principle, which states that we can observe our universe because it supports life, and the strong anthropic principle, which implies that the universe must have properties that allow for life to arise. The multiverse context allows for a more nuanced understanding of why our universe is the way it is, suggesting that life is not an extraordinary anomaly, but a natural outcome of a diverse multiverse landscape. 6. Other multiverse models. In addition to the primary types outlined above, there are other models and variations of multiverse theories. These include parallel universes. This concept suggests that there are universes that are similar to ours, but differ in certain aspects, such as historical events or personal choices made by individuals. Cyclic universes. Some theories propose that the universe undergoes endless cycles of expansion and contraction, leading to a continual rebirth of universes. Brane worlds. In string theory, our universe could be a three-dimensional brane floating in a higher dimensional space, with other branes representing different universes. Conclusion. The diversity of multiverse theories highlights the richness of our understanding of reality and the many ways scientists and philosophers are attempting to grapple with existence. Each type of multiverse theory offers unique insights into the nature of the cosmos, challenging our perceptions and expanding our horizons. As research continues to evolve, the implications of these theories will undoubtedly shape our understanding of the universe and our place within it, inviting us to explore the infinite possibilities that lie beyond our observable reality. Scientific evidence and support for the multiverse theory. The multiverse theory, while captivating, faces significant challenges in terms of empirical validation. However, there are several lines of reasoning and indirect evidence that support the possibility of multiple universes. This report explores the scientific foundations, observational evidence, and theoretical frameworks that bolster the multiverse hypothesis. 1. Quantum mechanics and the many worlds interpretation. One of the primary scientific bases for the multiverse theory arises from quantum mechanics, particularly through the many worlds interpretation, MWI, introduced by Hugh Everett III. In quantum mechanics, particles exist in a superposition of states until they are observed, leading to what appears to be a paradox. MWI resolves this by suggesting that all possible outcomes occur, each in its own branching universe. While NWI is not universally accepted, it provides a coherent framework for understanding quantum phenomena. Experiments like the double-slit experiment illustrate the strange nature of particles behaving as both waves and particles. If these interpretations hold true, it implies that every decision and event leads to a creation of parallel universes, supporting the multiverse idea from a quantum perspective. 2. Cosmic microwave background radiation. The cosmic microwave background radiation, CMB, is a remnant from the Big Bang and provides a snapshot of the early universe. Anomalies observed in the CMB could offer indirect evidence for the multiverse. For example, certain irregularities in the temperature fluctuations of the CMB might suggest interactions between our universe and other universes. One specific anomaly is the so-called cold spot, an unusually large area of the sky that is significantly colder than the surrounding regions. Some researchers propose that this cold spot could be a result of our universe colliding with another bubble universe during the inflationary phase. While this hypothesis remains contentious, it illustrates how cosmological observations can be interpreted to support the multiverse theory. The fine-tuning problem. The fine-tuning problem refers to the precise values of fundamental physical constants that allow for the existence of life. For instance, if the strength of gravity were slightly different, stars like our Sun might never form, making life as we know it impossible. This apparent design has led scientists to ponder why our universe is so hospitable. The multiverse theory provides a compelling explanation. If countless universes exist with varying physical constants, it is not surprising that at least one of them would have the right conditions for life. The anthropic principle supports this view, suggesting that we find ourselves in a universe capable of supporting observers precisely because other, less hospitable universes are also part of the multiverse. This reasoning has shifted discussions from "why is our universe fine-tuned?" to "in how many universes do life-supporting conditions exist?" 4. String theory and the landscape multiverse. String theory posits that fundamental particles are not point-like, but rather tiny, vibrating strings. This theory leads to a concept known as the landscape multiverse, where different configurations of strings yield a vast array of possible universes, each with unique physical laws. The implications of string theory are profound. With an estimated 10 to the 500th power possible universes, the landscape provides a natural framework for understanding why our universe has its specific properties. While string theory itself is still under development and lacks direct experimental evidence, its theoretical foundations offer a compelling argument for the multiverse. 5. Observational challenges. Despite the intriguing possibilities, one of the principal challenges of proving the multiverse theory is its inherent unobservable nature. Many proposed universes may be fundamentally inaccessible to us, as they might exist in dimensions beyond our current understanding or be separated by vast cosmic distances. This limitation raises questions about the scientific method itself. If a theory cannot be tested or observed, can it truly be considered scientific? Some argue that the multiverse theory may fall into the realm of metaphysics rather than empirical science. Nevertheless, the ongoing exploration of the cosmos and the quest for understanding may eventually lead to new methods of indirect verification. 6. Future directions in research. As cosmology advances, there are several areas of research that could provide further insights into the multiverse theory. Gravitational waves. The detection of gravitational waves offers a new avenue for exploring the early universe. Some researchers speculate that analyzing these waves could yield information about potential collisions with other universes. Particle physics experiments. High-energy particle collisions, such as those conducted at the Large Hadron Collider, LHC, may provide insights into the fundamental nature of reality that could support or challenge multiverse theories. Advancements in cosmological models. As our mathematical and computational models become more sophisticated, they may reveal new connections between quantum mechanics, inflation, and the multiverse. Conclusion. The scientific evidence supporting the multiverse theory is multifaceted, drawing from quantum mechanics, cosmology, and theoretical physics. While direct empirical validation remains elusive, several lines of reasoning, such as anomalies in the cosmic microwave background and the fine-tuning problem, lend credence to the idea of multiple coexisting universes. As our understanding of the universe continues to evolve, so too will our exploration of these profound questions. The pursuit of knowledge in this area not only deepens our understanding of the cosmos, philosophical implications of the multiverse theory. The multiverse theory, which posits the existence of multiple, potentially infinite universes, raises profound philosophical questions that challenge our understanding of reality, existence, and our place in the cosmos. As scientists explore the boundaries of this fascinating concept, philosophers are equally engaged in examining the implications that arise from the idea of a multiverse. 1. The nature of reality. One of the most significant philosophical implications of the multiverse theory is its challenge to our conception of reality. Traditionally, reality is understood as a singular, coherent entity governed by consistent laws of physics. However, the multiverse suggests that reality may be far more complex, comprising a vast array of independent universes, each with its own set of physical laws. This raises questions about what it means for something to be real. If there are countless universes with different properties, can we still claim that our universe is the only one that matters? The multiverse challenges the notion of a singular reality and invites us to consider a more pluralistic view of existence. 2. Identity and the self. The existence of parallel universes leads to intriguing questions about identity and the self. If every decision we make spawns a new universe, creating a version of ourselves that takes a different path, what does this mean for our understanding of personal identity? Are we defined by the choices we make, or is there a deeper essence that transcends these decisions? Philosophers have long debated the nature of identity, and the multiverse theory adds a new layer of complexity. It suggests that there may be countless versions of ourselves, each experiencing different outcomes based on our choices. This raises existential questions about the significance of our decisions and the uniqueness of our experiences. Free will and determinism. The multiverse theory also engages with the long-standing philosophical debate between free will and determinism. If every possible outcome of a decision occurs in a separate universe, does that imply that our choices are predetermined? Alternatively, does it provide a framework in which free will can coexist with a deterministic universe? Some philosophers argue that the multiverse allows for a form of compatibilism, where free will exists alongside determinism. In this view, while the outcomes of our decisions may lead to branching universes, we still possess agency in our choices. Others contend that this interpretation diminishes the significance of our actions, as every conceivable choice is realized in another universe. The anthropocentric perspective. The multiverse theory challenges the anthropocentric perspective, that is, the view that human beings hold a central place in the universe. If an infinite number of universes exist, each with its own life forms and ecosystems, what does that mean for humanity's significance? Are we simply one of countless intelligent species in a vast multiverse? This perspective can be both humbling and liberating. On one hand, it may evoke feelings of insignificance, as we realize that our universe is just one of many. On the other hand, it can inspire a sense of wonder and curiosity, as we consider the possibilities that other universes may hold. The multiverse invites us to rethink our place in the cosmos and to appreciate the diversity of life and existence beyond our own experience. Ethical considerations. The implications of the multiverse extend into the realm of ethics. If every possible outcome of a moral decision occurs in a separate universe, how should we evaluate the moral weight of our actions? Do our choices carry less significance if they are replicated across countless realities? Or does this multiplicity enhance the importance of making ethical decisions? Philosophers grapple with the consequences of the multiverse for ethical theories. For instance, utilitarianism, which seeks to maximize overall happiness, may be challenged by the existence of multiple outcomes. If one choice leads to happiness in one universe but suffering in another, how do we weigh the moral implications of our actions? 6. Existential questions. The multiverse theory inevitably raises existential questions about life, purpose, and meaning. If there are infinite versions of ourselves living out different scenarios, what does it mean to find meaning in our lives? Are we merely actors in a grand cosmic play, or do we possess the agency to create our own purpose? This inquiry into meaning can lead to a deeper exploration of personal values and beliefs. The possibility of multiple realities encourages individuals to reflect on what is truly important to them and to consider how their choices shape their experiences. In a multiverse, the search for meaning becomes a personal journey, influenced by the myriad paths available to us. Conclusion: the philosophical implications of the multiverse theory are vast and complex, touching on fundamental questions about reality, identity, free will, ethics, and meaning. As scientists continue to explore the nature of the cosmos, philosophers are tasked with grappling with the profound questions that arise from the idea of multiple universes. While the multiverse theory challenges traditional notions of existence, it also invites a deeper contemplation of our place in the universe. By expanding our understanding of reality, the multiverse encourages us to embrace the complexity of existence and to seek meaning in the diverse possibilities that lie beyond our observable universe. In doing so, we open ourselves to new realms of thought and reflection, enriching our understanding of what it means to be human in a potentially infinite cosmos. Cultural and popular representations of the multiverse theory. The multiverse theory, with its intriguing possibilities and profound implications, has permeated popular culture and inspired a wealth of creative expression across various mediums, from literature and film to television and video games. The concept of multiple universes has captivated audiences and sparked imaginative explorations of reality. This report delves into the ways the multiverse is represented in culture and its impact on public perception. 1. Literature, exploring infinite realities. The multiverse has long been a compelling theme in literature, allowing authors to explore complex ideas about identity, choice, and existence. One of the most notable examples is the Dark Tower series by Stephen King, which intricately weaves together multiple universes and timelines. The protagonist, Roland Deschain, embarks on a quest that traverses various realities, highlighting the interconnectedness of different worlds. Another significant work is Slaughterhouse-Five by Kurt Vonnegut. The story follows Billy Pilgrim, who becomes unstuck in time and experiences moments from his life out of order. The novel reflects on determinism and free will, echoing themes found in multiverse theory. Through these narratives, literature offers readers a chance to grapple with the philosophical implications of parallel realities. 2. Film, visualizing the infinite. In cinema, the multiverse has been depicted in various ways, often blending genres and challenging traditional storytelling. One prominent example is Everything Everywhere All at Once, a film that explores the chaos of infinite possibilities through the lens of a family drama. The protagonist, Evelyn Wang, navigates multiple universes, confronting alternate versions of herself and her loved ones. The film not only entertains, but also engages with existential questions about identity and the choices we make. Another notable film is Doctor Strange in the Multiverse of Madness, which delves into the Marvel Cinematic Universe's exploration of alternate realities. The film showcases the multiverse as a dynamic and often chaotic realm, filled with diverse characters and scenarios. By integrating the multiverse into popular superhero narratives, filmmakers have made complex scientific ideas more accessible to mainstream audiences. 3. Television. Series that bend reality. Television series have also embraced the multiverse concept, often using it as a narrative device to explore character development and thematic depth. Rick and Morty, an animated series that follows the misadventures of a scientist and his grandson, frequently ventures into alternate dimensions, each with its own unique rules and consequences. The show cleverly satirizes various aspects of science fiction and philosophy while incorporating multiverse theory in a humorous and engaging manner. Another example is Fringe, a series that revolves around a special FBI division investigating unexplained phenomena. The show delves into parallel universes and the implications of scientific experimentation, exploring themes of choice, sacrifice, and the nature of reality. By blending science fiction with procedural drama, Fringe captivates viewers while prompting them to consider the ethical dimensions of scientific discovery. 4. Video games. Interactive multiverses. The multiverse theme has also found a home in video games, allowing players to experience alternate realities through interactive storytelling. Games like The Legend of Zelda, Ocarina of Time feature time travel and alternate timelines, where players navigate different versions of Hyrule based on their choices. This engagement with branching narratives resonates with the multiverse concept, enabling players to explore the consequences of their decisions. Similarly, BioShock Infinite delves into parallel universes and the nature of choice. The game's central narrative revolves around the protagonist's journey through different realities, highlighting the impact of decisions on individual lives and the broader world. By immersing players in these complex narratives, video games provide a unique platform for exploring philosophical themes inherent in the multiverse. 5. Popular science and public perception. The multiverse theory has also infiltrated popular science, with books and documentaries aimed at educating the public about this complex concept. Authors like Brian Greene and Max Tegmark have written accessible works that explain the science behind the multiverse, making it relatable to non-specialist audiences. These contributions have sparked curiosity and discussion. Popular science shows such as Cosmos and Through the Wormhole have also featured segments on the multiverse, presenting the theory in an engaging manner. By blending entertainment with education, these programs have played a crucial role in shaping public perception and fostering a sense of wonder about the universe. 6. The impact of cultural representations. The cultural representations of the multiverse have significant implications for how the public understands and engages with scientific concepts. By incorporating complex theories into relatable narratives, creators have made the multiverse more accessible and intriguing. These representations encourage audiences to ponder profound questions about existence, identity, and the nature of reality. Furthermore, the multiverse concept has become a cultural touchstone, inspiring discussions about free will, destiny, and the moral weight of our choices. As audiences engage with these themes in various forms of media, they are prompted to reflect on their own lives and the infinite possibilities that lie within them. Conclusion: the multiverse theory has transcended the realms of science to become a rich source of inspiration in literature, film, television, and video games. Through creative expression, the concept of multiple universes offers audiences an opportunity to explore complex philosophical questions and engage with the nature of reality. as cultural representations continue to evolve, they will likely play an essential role in shaping public understanding and appreciation of the multiverse, inviting us all to ponder the infinite possibilities that lie beyond our observable universe. Current research and future directions in multiverse theory. The multiverse theory, while still a topic of debate within the scientific community, has gained traction as researchers explore its implications and seek evidence for its existence. As advancements in technology and theoretical frameworks continue to evolve, the investigation into multiple universes is becoming increasingly sophisticated. This report examines the current state of research surrounding the multiverse theory and outlines potential future directions in this intriguing field. 1. Advances in cosmology. Recent advancements in cosmology have provided new tools and methodologies for exploring the multiverse. The study of cosmic inflation, which posits that the universe underwent rapid expansion after the Big Bang, has opened avenues for understanding how different regions of spacetime might evolve into separate universes. Researchers are using observational data from telescopes and satellites, such as the James Webb Space Telescope, JWST, to investigate the early universe and gather insights into inflationary models. The JWST, launched in late 2021, has the capability to observe distant galaxies and cosmic phenomena with unprecedented clarity. Its findings could help distinguish between different inflationary models and provide indirect evidence for the existence of bubble universes. As the telescope continues to gather data, scientists are hopeful that it will shed light on the conditions that led to our universe's formation and whether those conditions may be replicated in other universes. 2. Quantum mechanics and experimental evidence. In the realm of quantum mechanics, researchers are exploring the implications of the many worlds interpretation, MWI, and its connection to the multiverse. While direct experimental evidence for MWI remains elusive, scientists are conducting experiments designed to test the principles of quantum superposition and entanglement. These experiments aim to provide insights into the nature of reality and whether multiple outcomes genuinely exist in parallel. One promising avenue of research involves the study of quantum decoherence, which explains how quantum systems interact with their environments and transition from superposition to classical states. By analyzing these interactions, researchers hope to gain a better understanding of the fundamental nature of reality and whether it aligns with the multiverse hypothesis. 3. String theory and the landscape multiverse. String theory continues to be a significant area of research in the context of the multiverse, as theorists work to develop a comprehensive framework that unites the fundamental forces of nature. The concept of a landscape multiverse emerges as a potential outcome. This landscape consists of a vast array of possible universes arising from different configurations of string theory. Researchers are refining mathematical models to explore the implications of this landscape, seeking to understand how different physical constants and laws emerge in various universes. As computational methods advance, scientists can simulate and analyze the properties of these universes, potentially identifying patterns that could lend credence to the multiverse theory. Gravitational waves and cosmic observations. The detection of gravitational waves has revolutionized our understanding of the universe, providing a new avenue for exploring cosmological phenomena. Gravitational waves are ripples in space-time caused by massive cosmic events, such as the collision of black holes or neutron stars. Ongoing research in this area may offer insights into the early universe and the conditions that could lead to the formation of multiple universes. Future observations of gravitational waves could also reveal signatures of interactions between our universe and others. For instance, if bubble universes collide, They may produce detectable gravitational waves that scientists could analyze. As detection technologies improve, the potential for uncovering evidence related to the multiverse becomes increasingly promising. 5. The role of philosophy in multiverse research. As scientific research progresses, philosophy plays a critical role in shaping the discourse around the multiverse theory. Philosophers are exploring the implications of multiversal concepts for our understanding of reality, identity, and ethics. As researchers gather more data and refine their models, interdisciplinary collaboration between scientists and philosophers can foster deeper insights into the implications of the multiverse. Philosophical discussions surrounding the nature of existence and the meaning of choice in a multiverse context can enrich scientific inquiry. By addressing the ethical and metaphysical questions that arise from the multiverse theory, philosophers can help frame the debate and guide future research endeavors. The future of multiverse research. Looking ahead, the future of multiverse research is vibrant and multifaceted. As technology continues to advance, scientists will have access to more sophisticated tools for observing the cosmos and testing theoretical models. The integration of artificial intelligence and machine learning in data analysis can enhance our ability to identify patterns and anomalies in observational data, potentially uncovering evidence for the multiverse. Furthermore, as collaborations between physicists, cosmologists, and philosophers deepen, the discourse surrounding the multiverse will likely expand. This interdisciplinary approach can lead to more holistic understandings of existence and reality, encouraging innovative thinking and new research directions. Conclusion: the exploration of the multiverse theory is an exciting and evolving frontier in science. Current research in cosmology, quantum mechanics, string theory, and gravitational waves is paving the way for deeper insights into the nature of reality and the potential existence of multiple universes. As scientists and philosophers engage in this endeavor, the implications of the multiverse will continue to inspire curiosity, wonder, and contemplation about our place in the cosmos. The journey into the multiverse is just beginning, and the discoveries that lie ahead promise to reshape our understanding of existence in profound ways. Conclusion: the enigmatic multiverse. The exploration of the multiverse theory represents one of the most profound and fascinating inquiries in modern science and philosophy. As we have seen, the multiverse concept challenges traditional notions of reality, existence, and our place in the cosmos, prompting us to reconsider what it means to be part of a potentially infinite ensemble of universes. A journey through complexity. From its historical roots in ancient philosophy to its contemporary manifestations in quantum mechanics, cosmology, and string theory, the multiverse has evolved into a rich tapestry of ideas that interweave science and philosophy. Each type of multiverse theory, be it the quantum multiverse, cosmic inflation, or the landscape of string theory, offers unique insights and challenges, expanding our understanding of what reality could entail. Current research is increasingly sophisticated, leveraging advanced technologies like the James Webb Space Telescope and gravitational wave detectors. These tools promise to deepen our understanding of the universe and potentially unveil evidence supporting the multiverse hypothesis. As scientists continue to push the boundaries of knowledge, the multiverse remains a tantalizing frontier that invites inquiry and exploration. Philosophical implications. The philosophical implications of the multiverse are equally profound. Questions about identity, free will, and the nature of reality take on new dimensions when considered in the context of multiple universes. The existence of parallel realities challenges our understanding of self and agency, urging us to reflect on the significance of our choices and experiences. Moreover, the anthropocentric perspective is called into question. as the multiverse suggests that humanity is but one thread in an intricate web of existence. Ethical considerations also arise, as the moral weight of our actions may shift in light of infinite possibilities. The dialogue between science and philosophy enriches our understanding of the multiverse, creating a fertile ground for new ideas and perspectives. Cultural resonance. Culturally, the multiverse has captured the imagination of artists, writers, and filmmakers, resulting in a rich array of representations across various media. Through literature, film, television, and video games, the multiverse has become a vehicle for exploring complex themes of existence and identity. These creative expressions not only entertain. The cultural resonance of the multiverse encourages curiosity and wonder, inspiring individuals to ponder their own lives in the context of infinite possibilities. By portraying the multiverse in relatable narratives, creators help bridge the gap between complex scientific theories and everyday experiences. Future directions. As we look to the future, the exploration of the multiverse is likely to continue shaping scientific inquiry and philosophical discourse. The ongoing development of observational technologies and computational models will enhance our understanding of the cosmos and may provide new avenues for investigating the multiverse. Interdisciplinary collaboration between scientists and philosophers will be crucial in framing the questions that arise from these explorations, fostering a holistic understanding of existence. Moreover, as public interest in the multiverse grows, further engagement through popular science communication will be essential. By making complex ideas accessible, we can inspire the next generation of thinkers and innovators to explore the mysteries of the universe. A call to wonder. In conclusion, the multiverse theory invites us to embrace the complexity and mystery of existence. It encourages us to ponder the nature of reality, the significance of our choices, and the potential for infinite possibilities. As we stand on the brink of new discoveries, the journey into the multiverse represents not just a scientific endeavor, but a profound philosophical exploration of what it means to be human in an ever-expanding cosmos. As we continue to seek answers, may we remain open to the wonders that lie beyond our observable universe, ready to explore the infinite possibilities that the multiverse holds. The quest for understanding the multiverse is not merely about uncovering scientific truths. It is about enriching our lives with curiosity, imagination, and a deeper appreciation for the complexity of existence. Thank you for watching. We hope you enjoyed today's video. If you did, don't forget to hit that like button and subscribe to our channel for more exciting content. Your support means the world to us. We can't wait to see you back here for our next adventure. If you have any feedback or ideas for future videos, drop them in the comments below. Until next time, take care and stay awesome. See you soon.